Alright, so in this video we're going to talk about the properties of the angles. So these properties only occur if the lines that are cut by the transversal are parallel. And usually our symbol for parallel lines is putting arrows on top of the line itself. Not at the end, but on top of the lines. So those guys are now considered parallel. So what does the alternate interior angles theorem say now? Well, it basically says that any angles that are alternate interior angles will be congruent to each other. So for example, 3 and 6, remember they are on opposite sides of their transversal, and they are in between the two lines that are intersected by that transversal, so they're alternate interior. And therefore, they are congruent, they are equal. So remember, we have two different angles here, two different sets of angles which are considered alternate interior. Okay, we have 4 and 5, and we have 3 and 6. Both of those are alternate interior angles. So what that means is if the measure of angle 3 is, let's say 60 degrees, it's going to do that, then angle 6 would be congruent, which means, definition of congruent angles means that they will be equal in measure. So angle 6, which is alternate interior with 3, would also be 60 degrees. Okay, so that's the alternate interior angles theorem. Theorems give us the properties, theorems and postulates give us the properties, where the definition just told us this is an alternate interior angle. Remember, this theorem is only true if the lines are parallel. Looking at the next one for alternate exterior angles. Okay, those are also congruent if the lines are parallel. Okay, if the lines are not parallel, then that is not necessarily true. So for example, angles 1 and 8 were alternate interior angles, right? So if the measure of angle 8 was 20 degrees, the measure of angle 1 would also be 20 degrees. All right, so that's the alternate interior or exterior angle theorem, which says that the alternate exterior angles are congruent if the lines creating them are parallel. Okay, consecutive interior angles. All right, so let's see, what's an example of consecutive interior? 4 and 6. Okay, consecutive interior angle, this is the one that's different. Okay, we abbreviate this one CIA theorem. Okay, and I like CIA's the sneaky, tricky one, okay, because it's the one that's different than the rest. And this one's different because it says that basically those two angles are supplementary. In other words, the measure of angle 4 plus the measure of angle 6 will equal 180 degrees. All right, so let's say the measure of angle 4 equals 70 degrees. The measure of angle 6, since they're consecutive interior, and I forgot, these lines are parallel. It has to be shown to you in some way, either marked or written in the given. Okay, and so if the measure of angle 4 is 70, the measure of angle 6 is 110, making sure they add up to 180. So that's the consecutive interior angle theorem. All right, and the last one is the corresponding angle postulate. So let's look at an example of corresponding angles here. 1 and 5 are corresponding. Corresponding angle postulate, remember difference between postulate and a theorem, kind of same thing except for a postulate is does not need to be proven. Okay, it's assumed to be true. It's kind of like common mathematical sense. Okay, but angles 1 and 5 will be congruent. Okay, so let's say the measure of angle 5 is 70 degrees, then the measure of angle 1 would also be 70 degrees. So corresponding angles, if they have parallel lines, forgot to mark those parallel, okay? If they have parallel lines there, are going to be congruent in every single case, and that's because of the corresponding angle postulate.